Welcome back. The objective of this video is to write a complex number in polar form and also take numbers that are in polar form or trig form and rewrite them into standard form or rectangular form. Let's start by rewinding the clock a little bit. Let's take a look at what we've seen with polar form of a complex number. So recall that a rectangular form, z equals a plus bi, we have our real part and our imaginary part of our complex number. Well, we can say that cosine of theta, we've known that now as adjacent over hypotenuse or x over r. Well, our x is our a value, so we can rewrite the cosine of theta as a over r. And of course, multiplying both sides by r, we can say that r cosine of theta does equal a. And we can do the same thing for sine. Sine, right, is opposite over hypotenuse or y over r, but our y value in complex form is b, so we have b over r. Multiplying both sides by r, we get r sine of theta is equal to b, or our y. So that's our former y, and that's our former x. And if we have a particular point, we've got a magnitude here of z. Sometimes it's written with double parentheses. I've seen it both ways now. And our y value, our imaginary portion is b, and our real axis is a. And we can rewrite this into polar form. So z as trig, if a is equal to r cosine of theta, and b is equal to r sine of theta, we can say that z, or a, is equal to r cosine of theta plus b, r sine of theta, or r I sine of theta. If we factor out the r, we can get z equals r times cosine of theta plus I sine of theta. So we'll see that written now or called polar form or trig form. So a lot of times we'll use the bottom one here. So keep in mind trig form. So make sure you got that in your notes. So a complex number, a plus z equals a plus bi, has the polar form or trig form of r cosine of theta plus I sine of theta, where the magnitude of z equals the square root of a squared plus b squared, and the tangent of theta is b over a, or our y over our x. The number r is the modulus of z, and theta is the argument of z. So you'll also see that vocabulary, modulus and an argument, or our a and our b, or our x and our y. In example 12, we're asked to write the complex number z equals the square root of 3 plus I in polar form. So our coefficient on I is 1. Our a value is the square root of 3. Our b value is 1. So r could equal the square root of the square root of 3 squared plus 1 squared. So 3 plus 1 is 4. The square root of 4 is 2. So some of you guys might recognize this. Our a value is the square root of 3. Our b value is 1. This is 1. Square root of 3. Our z value is 2. You might see this as a 30, 60, 90 right triangle, where our theta here has to be pi over 6, or 30 degrees. Our theta, if we wanted to do this, we would say the tangent of, well, the arctan of b over a, 1 over the square root of 3 is equal to theta. If we went to our unit circle, we would see that theta equals pi over 6. So now that we've got everything set up, now we have to write it into polar form. So our polar form, z equals r cosine of theta plus I sine of theta. And our r is 2, so 2. And we know our theta as well. Our theta is pi over 6. So 2 cosine of pi over 6 plus I sine of pi over 6. And that is our final answer. That is our polar form, or our trig form, of the square root of 3 plus 3i. In example 13, we're given the square root of 6 minus I over the square root of 2. We were asked to write that in polar form. So again, we're trying to find z equals r cosine of theta plus I sine of theta. So we need both r and theta. So I'll write that over here in the left margin. That's what we need, so we can fill in our final form. So our a value is the square root of 6. Our b value is the square root of 2. Our r is the square root of the square root of 6 squared plus the square root of 2 squared. So r is equal to the square root of 8, which is 2 square root of 2. Our theta, well, arctangent of the square root of 2 over the square root of 6 equals theta. Let's go ahead and draw this out. This might answer some questions for us. We could put this in our calculator, but believe it or not, I know the answer, so I know this is on our unit circle. But if I sketch this out, I've got an a value of the square root of 6 and a b value of negative square root of 2. So here we need our z, or our r value we want, and here's our theta. If I do some thinking, though, square root of 6 is the same as the square root of 2 times the square root of 3. So if you're really on top of things, this is x root 3, and so the hypotenuse here has to be 2x. This again is a 30, 60, 90. Down in quadrant 4, this is a negative pi over 6. So now I have my r value of 2 square root of 2. I have my theta of negative pi over 6. So I can write this as z equals r cosine of negative pi over 6 plus I sine of negative pi over 6. You may also see that, oh, I didn't put my r in, I better fix that. My r value is 2 square root of 2, and that's always positive. So negative pi over 6, you may also see that as 11 pi over 6, depending on what the range is asked for, or what our interval for theta is. So it is possible you might see this as 2 square root of 2 times, I don't think I'm going to fit all this in, but will be the cosine of 11 pi over 6 plus I sine of 11 pi over 6. So that might be another possibility for that particular answer. Examples 14 and 15 change polar form to rectangular form. And question 15, write the complex number in standard form. Different questions, but the exact same process. So same process for different vocabulary. So let's take a look at what's going on here. And let's start with 14. So we have z equals 5. Well, the cosine of 3 pi over 4, we can pick that off of our unit circle and simplify that. That's just negative square root of 2 over 2. And the sine of 3 pi over 4 is the square root of 2 over 2. So z is equal to negative 5 square root of 2 over 2 plus 5I square root of 2 over 2. And that is our rectangular form of that answer. In problem 15, our process is the same. We're going to write the complex number in standard form. We just have a different location here. Cosine of 4 pi over 3, I sine 4 pi over 3. Again, on our unit circle, I did fill in the unit circle for the 3 pi over 4. But 4 pi over 3 is going to be down here in the third quadrant, where our cosine is negative 1/2 and our sine is negative square root of 3 over 2. So we have z equals 3 times negative 1/2 plus negative square root of 3 over 2, or 3I square root of 2. So z equals negative 3/2 minus 3 square root of 3, well, I could say 3I square root of 3 all over 2. And that wraps up this video of switching between trig form or polar form and rectangular form of complex numbers. And we'll get some more practice with this when I see you in class.